Hello, am I audible? If anyone can confirm.
We can hear you.
Okay, so welcome everyone. Hope you are doing well. Good morning, good afternoon, good evening on the basis where you all are joining us. Today we will be joined by Will Thompson. He will be talking about how to automate your Flatpak manifest updates. Will Thompson is the director of platform at Endless OS Foundation, a non-profit whose mission is to help everyone who want to connect with technology. Will be coming on the stage soon. So if anyone is not familiar with the interface, let me tell you, if you have any questions, you can either post them in the public chat, or there is a option at the notes, shared notes. You can post your questions over there also and have fun. Thank you.
Hi there, thanks for the introduction. So good morning from London in the United Kingdom. My name is Will Thompson. I'm an engineering director at Endless OS Foundation. As we just heard, our mission is to help all peoples and communities connect with technology. I'll tell you a bit more about Endless OS itself later. Today I'm going to talk mainly about Flatpak External Data Checker, which helps keep Flatpaks up to date with new releases of the app or its dependencies. I'll explain what it does, tell you a bit about its history, and what it's doing today. I'll give some examples of how you can use it yourself and some ways that you could get involved in the project. We'll have some time at the end for questions, so if you do have any questions during the talk, please leave them in the chat or the shared notes, and we'll get to them at the end. If you're watching the recording and have any questions, then please do get in touch. My email address is on the slide, and we'll have the URL to the project itself later in the deck. Okay, so a bit of context. To understand the motivation for this tool, it helps to know a few facts about Flatpak itself. I'll quote the tagline from its website. Flatpak is a next-generation technology for building and distributing desktop applications on Linux. We're mostly focusing on the building and distributing today rather than the running. But applications are built and run in a predictable environment, regardless of the Linux distribution that they're running on. And anyone can host a repository of Flatpak applications, and users can have applications installed from more than one repository at the same time. Probably the most prominent Flatpak repository is FlatHub, which is a vendor-neutral project which hosts a mixture of open source and proprietary applications. And that's the one I'm going to be concentrating on today. But whenever I say FlatHub, you can imagine there's a footnote saying, or another Flatpak repository which works kind of like FlatHub. So on FlatHub, footnote, the build process for most apps is defined by what's called a manifest file, which is in a JSON or YAML format. And that's stored in a repository on GitHub within the FlatHub organization. And these manifests are essentially a list of all the app's dependencies and the app itself, and how to build and install each of those components in sequence. First, each dependency, followed by building and installing the app itself. And the source code for the app and its dependencies is not stored in that Git repository. It just contains this manifest. The manifest contains URLs to each source code artifact. And when FlatHub builds the app, it downloads all the source as specified in the manifest. For some apps, the manifest is very simple because all the necessary dependencies are already present in the Flatpak runtime. So for these, the manifest would literally just be, here is the source code for this app, and here's how you build it. Done. For other apps, often big Python apps or big Node or Electron apps, there are hundreds or maybe even thousands of dependencies. And those apps manifests are generated by tools which read these language-specific formats and emit gigantic JSON files in the format understood by Flatpak Builder. Most apps are somewhere in the middle with a small handful of dependencies and a manifest maintained by hand. And those are the kinds of apps that this tool is intended to help with. Just while we're here, two of the other prominent Flatpak repositories you may have come across are the Gnome Lightning repository, which holds as the name suggests, nightly builds of the development branch of GNOME components. And there's also Fedora's Flatpak repository. Apps in those repositories tend not to need the kind of automation we're talking about today. And in the case of Fedora, the Flatpaks are built by a completely different process, and this tool is not relevant at all. If you're interested in how those ones are built, then stick around for the next talk in just under an hour when we'll hear about that. OK. Normally, when FlatHub builds a Flatpak application, the resulting files are stored as an immutable OS tree snapshot, which users then just download from the repository and run straight from disk. But Flatpak does have a somewhat unusual feature, which allows an app to download and unpack additional files from a third-party server at the time when the app is installed. This feature mainly exists to support installing applications using Flatpak when the repository owner doesn't have permission to redistribute the app itself. So for an example, here is what happens today if you install Skype from FlatHub using the command line or using GNOME software or another front end. So first of all, Flatpak running on your computer fetches and installs the com.skype.client Flatpak from FlatHub. It also fetches the runtime that it depends on if you don't already have it installed. So that Flatpak app, com.skype.client, it contains the open source libraries that Skype depends on. That's things like v4l utils to talk to the webcam and libsecret to talk to your keyring. But it doesn't actually contain Skype itself. FlatHub does not have permission to redistribute Skype. So instead, the Flatpak contains the URL to the deb package of Skype, the expected size in bytes, and the SHA-256 checksum of that file, and a script, which will be used to unpack that deb file. So next, having downloaded the app minus the app itself and the runtime from FlatHub, Flatpak running on your computer downloads the Skype deb file directly from Skype. It verifies that the deb file has the expected size and checksum, and if it does, it will run the script that was included in the Flatpak app to unpack it. And this script is run in a strict sandbox, and once it's finished, the files it's extracted are made read-only, just like all the other files in a Flatpak app. FlatHub didn't distribute Skype itself, but the end result, once you install the app, is almost the same as if you had. You can treat it as just like any other Flatpak app. You can update it in the background while it is running, and the next time you start it, you'll get the new version. You can uninstall it. Mostly it behaves just as you would expect. Maybe as I was saying that, you can think of some ways that this process might go wrong. So when a new version of Skype is released, the URL for the old version will eventually stop working. And so if the Flatpak app, which contains the URL to download it from, is not updated before that point, new users will not be able to install this new release of Skype, or in fact, they won't be able to install the old one either. And if you already have Skype installed in your system with Flatpak, you won't be able to update it. It will keep working, but you can't update it. And even worse, sometimes vendors publish a new version of their app at the same URL as the old version. And so, of course, the new version will have a different size and checksum, and Flatpak will refuse to unpack it when you try to install it. And so, again, installation will fail. And this is worse because it happens immediately that the new version is released. It's, there's no grace period where the old file is still kicking around in the repository or on their CDN. Like, done, doesn't work anymore. So we do need a way to keep these Flatpaks, which are extra data, up to date, and ideally do this automatically. It's time for a bit of a history lesson. If you cast your mind back to the middle of 2016, but try not to think about the politics stuff and concentrate on the computers. So back then, at the start of 2016, Flatpak did not exist, but a precursor tool called XDG-app existed. So during 2016, that was rebranded as the much snappier and easier to say Flatpak. And Endless OS was being rebuilt from using a bespoke app management tool to use Flatpaks for apps. I borrowed this image, which is a kind of publicity image of Endless OS at the time, from the press release which announced Flatpak back in 2016. So if you're not familiar with Endless OS, it's a desktop OS with some properties borrowed from mobile OSs. So behind the scenes, rather like iOS and Android, and rather unlike most traditional Linux distributions, each release of Endless OS is an immutable OS tree snapshot. So although it's derived from Debian, it's not possible to install new apps using tools like dpackage. Updates for Endless OS are distributed as new OS tree snapshots, which are unpacked, and then you reboot, and you're in the new version atomically. As you may know, Flatpak uses OS tree behind the scenes for its own snapshot-based installation and updates, and so we adopted that on Endless OS. Apps on Endless OS can be installed using Flatpak, which means every app, just like the OS itself, is a hermetically sealed snapshot. One of the really nice things this enables is robust automatic updates, both of the OS and of the apps themselves. Many of our target users are not computer savvy. Having to manually operate updates, decide whether they want to reboot their computer or not, is not something we want to do. And we've been very happy just allowing the OS and the apps to update themselves automatically. This is very robust, it works very well, and it's basically invisible, which is exactly what you want. So Endless OS has many unique apps for offline contents, be that copies of Wikipedia, other tutorials and guides, how to use Blender, and so on. These are built using a custom Flatpak runtime and a custom build pipeline, and they're published in our own Flatpak repository. But of course, users need regular apps too for productivity and creativity and chaos. So back in 2016, FlatHub didn't exist. So we built and published Flatpaks for a bunch of third-party apps in our own Flatpak repository too, alongside our first-party content apps. Most of these apps were open source apps, but our users expected to be able to install some apps such as Skype, Spotify, and Dropbox, which happened to be the first three when I did some history research preparing this talk. So those three were built as extra data Flatpaks using the mechanism I just described. Joachim Ruscher, who worked at Endless at the time, wrote a Jenkins job, which would check for new versions of these apps, and it would just email the Endless engineering team when the Flatpaks needed to be updated. So as the list of third-party apps grew steadily larger, the script got more complicated to deal with different ways to check for updates. So Joachim rewrote it in Python, and he published it as the first version of Flatpak External Data Checker, the subject of today's talk. So fast forward a couple of years, and in 2018, FlatHub was born. We quickly enabled it by default in Endless OS, and we began moving these third-party apps from our own Flatpak repository into FlatHub. All the open source ones and the few that were using extra data. So I found a funny commit from Nick Richards from July in 2018. Nick used to work at Endless, and he's still very involved in FlatHub today. The commit message reads, check extra data for most FlatHub repositories. But as you might be able to see here, most means 16 apps. FlatHub has come a really long way in these 3 years. At this point, the process was still the same as when it was first created. When an app needed to be updated, the dev team at Endless would get an email from Jenkins, and someone would have to go and manually update the relevant manifest file. It came to pass that I was often the one who got those emails. I got tired of doing it by hand, and I love to spend more time than is really advisable automating simple tasks. So at the start of 2019, I taught Flatpak External Data Checker to update the Flatpak manifest and open a pull request. So at this point, it was still running out of Endless's Jenkins. As you might be able to see from this screenshot, there's this cryptically named GitHub user EOS shell build. This seems to have been the first pull request it opened, at least on FlatHub, and at least when running from our Jenkins rather than me running it by hand on my development system with my own API key as my own GitHub user. This first pull request was actually declined because somebody manually opened another pull request for a slightly newer version of Dropbox shortly afterwards. But if they had not done so, this would have been just grand. One of the really nice things about this workflow is that FlatHub has continuous integration, which automatically makes a test build of every pull request. So as a maintainer, you receive a pull request, and shortly afterwards, you have a URL that you can use to just install and test that test build. Copy paste it, run the app, and assuming it works, you just hit merge on the pull request, and that's it. No manual editing of JSON files. So, Bartłomiej Piotrowski is a DevOps engineer at the Gnome Foundation, and he's one of the main administrators of FlatHub. So near the end of 2019, he deployed Flatpak External Data Checker onto FlatHub's own infrastructure, and we moved the repository over to the FlatHub organization. So outside of the endless GitHub and CI, and it's now a shared FlatHub project. He set it up to run every hour and check every app on FlatHub which had the appropriate configuration in its manifest to allow the tool to work. So making this tool more official had some nice results. Before that, some FlatHub contributors had been a bit hesitant to integrate with a tool that was running on Endless's private CI infrastructure. It's a bit opaque. But as part of the FlatHub organization, they were happy to opt in, safe in the knowledge that the FlatHub administrators could intervene as needed. It was also made a requirement that if you submit a new extra data app to FlatHub, then it should integrate with this tool where possible. And so, of course, that also helped with its adoption. So taken together, these in turn led to more people contributing to the external data checker itself. This seems to have been the first pull request that was opened by the FlatHub instance of the checker, which, funnily enough, also seems to have been declined. It's running as the GitHub user FlatHub bot, which is also the user which announces the URLs for test builds. But those two systems actually don't really know anything about each other. They happen to run as the same GitHub user, happily coexisting. What you might also notice here is that it hasn't just updated the URL now, it's also updated the app data file with the version number and release date of the new build of Zoom. So it's extracted that from the URL and put it into the XML, which reduces one extra step you might have to do manually when you get an update. When it was rolled out to FlatHub, something interesting and a little bit unexpected happened. So although Flatpak External Data Checker was originally created to update extra data Flatpaks, but it started to be adopted by regular Flatpaks to keep them up to date as well. When I prepared this talk, there were 112 apps on FlatHub which have ever been updated by this tool at least once in their history. And out of those 112 apps, only 36 are extra data. And so that is the blue line in this graph. The remaining 76 apps are normal Flatpaks that FlatHub can build and distribute in full and which will not break if the dependencies go away, because the build is committed and saved in FlatHub's infrastructure. Actually, the source code is too. So if the upstream goes away, we've got it back up. So the red line in this graph are the normal Flatpaks, which are being updated by Flatpak External Data Checker. So you can probably see that both lines went up steadily over the course of 2020, which is after this tool was deployed to FlatHub at the end of 2019. There's a nice bump right at the end of 2019, around here. And I think this is the day that we merged support for updating JetBrains IDEs, which was contributed by LCTRS. Since there were about 6 of those on FlatHub already, they all adopted it simultaneously. You can probably also see that this checker really exploded in popularity for normal Flatpaks since the start of this year, 2021. So this year starts around here, and the line just shoots up. I think this is mainly because a prolific FlatHub contributor who goes by the username Gas in Vain became a co-maintainer of the Flatpak External Data Checker near the end of 2020. And he contributed really a lot of nice improvements. Motivated by trying to keep up with the rapid release schedule of the open source Telegram app, he added several new ways to look for updated versions, such as by checking releasemonitoring.org and using a general purpose JSON parser, both of which we'll talk about a little more later. So as well as Telegram, this made it possible to check and update many more apps automatically than was supported before, when the tool was targeting extra data apps. And if we switch to looking for a moment at the contributions to the external data checker itself, I think the graph of commits and number of lines changed speaks to the scale of his contributions to this project. You can see this gigantic mountain which emerges in 2021. I have to confess that I've actually barely worked on this tool myself this year. So I'd like to thank Gas and Vein and actually everyone who's contributed over the past 2 years for keeping this project moving along. Okay, let's get back to what the tool does. So here I've plotted the number of repositories to which an update from Flatpak external data checker was merged in any given month. So this shows in blue the number of commits and in red the number of repositories. Not every app has an update every month, which is why the number of repos updated in the past few months is just 50 or so compared to the 100 or something in total over the last 2 years. The number of commits that it makes is consistently much higher than the number of apps. So it's updating some apps multiple times per month. For the last 2 months, there's been more than 100 updates per month. And here are the top 30 apps and runtimes that it updates, because one of the other things it learned to do as a result of these changes is to update runtimes, which are used, as the name suggests, to run apps, but also to build time and as extensions to apps. And so this chart is the number of commits ordered by Flatpak external data checker. I've colored the bars by whether the app is extra data or not. But I've just realized that the colors are the opposite way around compared to the earlier slide. Sorry. So here, the extra data apps are red and the normal apps are blue. This chart doesn't take time into account, so it will obviously be biased towards apps which have been using the tool for longer, as opposed to apps which adopted it recently. But even so, you can see quite an even split between extra data and normal apps. The third most frequently updated app is RPCS3, which is a PlayStation 3 emulator, apparently, which is released under the GPL. FlatHub tracks the master branch of that project, which is a little unusual. Typically, FlatHub contains releases of apps. But I guess this is one of these fast-moving projects where if you're at the bleeding edge, you're likely to get better compatibility with games, and the cost of an occasional broken build, if master is broken in the upstream project, is not so great. So the trade-off is worth it. High up on this chart, you can also see the Rust nightly extension, which is the nightly build of the Rust toolchain, which is, of course, open source, as well as the insiders branch of Visual Studio Code, which is not open source. And that made me wonder, if so many of the most frequently updated repositories are actually open source, or if they're not open source, they're redistributable at least, how does that compare to the proportion of apps of each kind on FlatHub as a whole? So as I mentioned, of the 112 repos that the checker has ever updated, only 36 are extra data, and the remaining 76 are normal, fully redistributable Flatbacks. And that's almost as many as the 79 extra data apps that FlatHub has in total. So in relative terms, the checker checks almost half of the extra data apps. And there are so many other apps on FlatHub, it only checks 5% of those so far. If you're wondering why this chart suggests there are almost 1,600 apps on FlatHub, whereas if you ask the Flatpak command line to list the apps in FlatHub, and it will give you more like 1,200, this is because the analysis is quite simplistic. I'm including end-of-life apps, of which there are perhaps a few dozen, but I'm also including runtimes and extensions. And one thing I learned in the last couple of weeks is that there are more than 100 plugins for digital audio workstations on FlatHub. And I think it's reasonable to count those. Unfortunately, those are all in the doesn't use the checker category so far. Anyway, personally, I find these numbers pretty reassuring. I think it's reasonable to ask, is it really desirable for FlatHub to be publishing extra data wrappers for proprietary apps? Even if you ignore the free software angle, I'm going to quote from the FlatHub website that FlatHub is primarily intended as a service which is used by app developers to distribute their apps. And we would prefer that applications on FlatHub are controlled by their authors. So is this tool making it almost too easy to publish either exploited wrappers or unofficial open source builds, rather than encouraging the app developers themselves to publish their own apps directly to FlatHub. So like FlatHub as a whole, I think, I take a pragmatic stance on this. There are some apps that people really do need to be able to run on their computers. The last year has shown us that running apps like Zoom and Microsoft Teams and so on is, for better or for worse, it's not a matter of choice for a lot of people. They need these apps to continue working or studying. At least by distributing them with Flatpak, there's a chance that they are more tightly sandboxed than a traditional distro package would be. And because Flatpak apps can be safely upgraded in the background automatically, even when the app is running, if we can streamline and automate updating these apps on the server, then this potentially means that new versions reach the users more promptly. And all those things I just described are obviously true for open source software as well, which, as we just saw, is 95% of the software on FlatHub. And Flatpak External Data Checker evidently helps many people to keep those apps up to date as well. One very important class of software which really needs to be kept up to date is web browsers. Chromium, for example, has been on FlatHub for about 6 months. Chromium has a very rapid major release cadence. I think historically it's released every 6 weeks, and I saw some news about them trying to increase that speed to releasing every 4 weeks soon. And even given that it releases so often for new major versions, it's pretty common to see one or more point releases in between, and those almost always fix very serious security vulnerabilities. The Chromium repository on FlatHub is naturally wired up to Flatpak External Data Checker. So when a new release appears of Chromium, published by Chromium, the Chromium project, a pull request is pretty quickly created and a test build is made by the FlatHub CI. Major upgrades of Chromium tend to need manual intervention because the FlatHub version has a dozen or so patches to better integrate with Flatpak. If we get lucky, those build cleanly, but often we don't. But these point releases do tend to build cleanly. Back when we used to have Chromium as a distro package in Endless OS, any point release involved a developer manually rebasing the package in our stack of patches, building it, which takes hours, and then you test it, and then you release it, and then, of course, it was built into the OS, and the OS is updated as a snapshot as a whole, so we'd have to decide whether to adjust the OS release schedule or delay getting the updates out to users. So making the browser a Flatpak has removed that last component, and automating these updates has meant for a much better workflow. A Chromium release is published, a pull request appears, a few hours later, it still takes a while to build Chromium, even on a very powerful build server, but a few hours later, a test build appears, and someone can test it, and in the happy path, they press merge, and it goes out to users within a few hours, potentially, of being published, which is a much more responsive workflow. From the kind of first-party app publisher perspective, I publish a few of my own apps on FlatHub. And even in the case where I'm publishing my own app, it's really nice to have a computer program do this boring work of updating a JSON file for you. I also somewhat maintain the Flatpaks for maybe a dozen more apps, mostly open source. And for example, getting notified of a new upstream release of TuxPaint in the form of a pull request that I can easily test really makes this a lot more manageable. Of course, there are other models of publishing new versions of apps into a repository like FlatHub, which could work just as well or maybe even better. Sticking with web browsers for the time being, the Firefox Flatpak on FlatHub comes directly from Mozilla. And rather than being built by FlatHub, it's the binary directly from Mozilla, which is pushed directly into FlatHub by Mozilla's release process. So security updates for Firefox hit FlatHub the moment they're released by Mozilla without any intervening delay. There are downsides to this model as well. There's less visibility for FlatHub into how this app is built. But for apps like Firefox, having the official package and the official bytes of the binary built by Mozilla pushed immediately into FlatHub makes a lot of sense. Okay, hopefully I've convinced you that this tool is useful to you as an app developer. Or maybe you're submitting an extra data app to FlatHub and you've discovered that this tool is mandatory. Okay, how do you actually use it? The short version is you generally just need to add some special annotations to the app's manifest to tell the external data checker how to keep it up to date. It's got about a dozen different checkers for various scenarios. I won't describe them all here, but I will give a few illustrative examples. In case you're not familiar with Flatpak manifests, most of what you see here is quite standard. This is an excerpt from a JSON file which tells Flatpak how to build the Zoom Flatpak, lowercase f, uppercase f. And this section is the extra data source for Zoom itself. It tells Flatpak that it's an extra data file, that it's only available for 64-bit Intel platforms. It has the URL from which you can download the file. It has the SHA-SUM expected, and it has its size. And this X-checker data section is specific to Flatpak external data checker, and it's ignored by Flatpak Builder when it's building the Flatpak. So in this case, Zoom has a magic URL, which is zoomed out, a magic URL, which always redirects to the latest version of the app. So in this X-checker data section, we tell the tool to use the rotating URL checker, which expects this behavior of one URL which redirects to the real URL for the app. And we provide a regular expression with a match group here, which extracts the version number from that target URL. And that's all the configuration that's needed. Every hour, FlatHub runs the checker on this repo, and the checker will poll this URL, find out what it redirects to, and if it finds an update, it will open a pull request. And because we told it how to extract the version number, as we saw earlier, it can also update the app data file in the repository. Here's another example, this time using YAML syntax. The two are interchangeable for Flatpak manifests. This is for Unity Hub, which is an app that can be used to, in turn, download and run Unity, which is a popular game development platform. Unity Hub is distributed by Unity only as an app image file, which, funnily enough, is a competing Linux app distribution tool. Here we are. Flatpak external data checker has special handling for app image files. In particular, it knows how to unpack them and look inside to work out what the version number is. And Unity Hub is actually an example of the situation I described earlier. Each new version of the app is published at the same URL as the old one. So each time a new version of Unity Hub is released, the Flatpak immediately stops being installable until we update its manifest on FlatHub. When we first added Unity Hub to FlatHub, we forgot to add this app to the big endless job that's checked Flatpaks, and the app broke almost immediately, and we didn't notice for a few days. So generally, a human being is expected to actually test each app update before publishing it on FlatHub. And so in the normal case, the external data checker just opens a pull request and it waits for a human being to come along and test it and merge it. But in this case, it can tell that the existing version is broken because it's the same URL with a new checksum. And so it will automatically merge its own pull request, provided that the CI checks, which check that the manifest is well-formed and builds, pass. So the silver lining here is that there's no configuration needed at all. The checker has special handling for app image. It runs on this repository. It fetches this URL. If it finds that its SHA-SUM and size have changed, it sends a pull request. And then the next time it runs, it will check in on its own pull requests. And if the CI has passed, it merges it. No extra configuration needed at all. I mentioned earlier that Gassenvein added a backend for releasemonitoring.org, which is also known as Anitia, and it's maintained by Fedora, I think. So if you're the developer of an open source Flatpak application, or you maintain a Flatpak for one, this could be particularly interesting for you. This is the example of how that's used for the Chromium Flatpak. we need to give it a numeric ID for the project, which you can find from the releasemonitoring.org website. Tell it to only get stable versions of Chromium, and provide it a template for how to build a URL for a given version. And that's all the configuration. The only other difference here you may have noticed is that the source is of type archive, not of type extradata. So this is because this component is downloaded and compiled at build time on FlatHub's build server rather than on the end user system. Chromium is a normal Flatpak. There are similar checkers for Gnome components and PyPI packages and Rust packages and so on. Here's a slightly more complicated example. I mentioned earlier that Telegram is the motivation for a more general purpose JSON plugin. There are 4 inputs to the checker. In this example, there's the URL of the JSON file. There is 3 query expressions which tell the checker how to find the get tag, the timestamp at which it was made, and how to parse that tag to work out the version. These are using the syntax of the popular JQ JSON processing tool, which the checker actually uses internally to do this. You might hope that you can handle get tags, unfortunately, automatically, but it's not always that simple for various tedious reasons. But the JSON checker is a really powerful tool that can be used for all kinds of sources, not just releases on GitHub. Having said that, there are some cases when you can just handle get tags more straightforwardly. So this is an example of updating a dependency rather than the app itself. It's from Remina, which is an open source remote desktop client with many, many dependencies, most of which have the right annotations to be automatically updated. So here's an example which checks for new Git tags matching a regular expression in the repository for this dependency of this app. There are some rare occasions when you actually want the checker to automatically merge its own pull request. There's a FlatHub beta repository which contains apps which, for whatever reason, aren't for general consumption. And the unstable channel of Visual Studio Code is published there, the insiders build. And the whole point of that build is that you want to get early access to features and stuff that might be broken. And so again, it's worth the risk of the occasional broken version of the app to get that automatically. And so the VS Code insiders build opts into that auto-merging behavior, even in the case where the old version works fine, by setting a file in the flathub.json file in the repo. How do you actually test it yourself? Rather than, you could just edit the file, push the FlatHub and wait an hour and see what happens, but you can run the tool very simply yourself. It's published as a Flatpak on FlatHub, and of course, it keeps itself up to date automatically. It's not visible in front ends like Gnome software, so you need to install it from the command line. And having done that, you need to pass it the right arguments to give it access to the manifest file it's going to update. By default, it can't touch your file system at all. Also, by default, it just prints out what it would like to do. There's an edit-only flag which tells it to write the changes back to your working copy, but not actually commit them or open a pull request. There are other flags you can find with the --help to tell it to do different things. If for some reason you prefer Docker or Podman, maybe you want to run it in Jenkins, it's also available as a Docker container in the Github Container registry, which works pretty similarly. And for developments, there's also a Docker file in the repository, and that might be helpful if you want to get involved in developing it. So speaking of which, here's where it lives. There are some future plans, kind of fuzzy. I mentioned earlier that for Node and Python apps, there are often very, very large automatically generated manifests. It would be interesting to teach this tool to automatically update those as well. You could also conceivably teach this tool to automatically update the runtime that the app uses. So there are plenty of ways you could get involved in contributing to the tool, but perhaps the most obvious one is to start using it yourself and give feedback on how it works for you. If you're keen on writing documentation, the perspective of a new user is always very, very valuable. You could also contribute checkers for new software sources, or maybe add some magic to some of the existing ones. And actually, over the course of this talk, I've realized that saying Flatpak external data checker over and over again is quite clumsy. So maybe you can think of a snappier name and a cool logo. That would be great stuff as well. That's all I have today. Thanks again to everyone who's contributed to this tool over its lifetime. It's come a very long way from a bash script on a private Jenkins instance. The code I use to generate these graphs is at this repo. Any questions?
Yeah, hello. Well, we have some questions in the shared notes. If you, I can read it for you.
Great.
So first question is, can this tool be used to automatically update the runtime to use so we can avoid apps using deprecated Gnome, KDE, or free desktop SDK, etc. runtimes?
Great question. Yes, as I just mentioned, the answer is no today. It only updates components of the app itself. Updating the runtime seems like a nice feature to add, particularly given we have all of the infrastructure in place to run the tool, check every repo, open pull requests, and so on. I think the key word in that question is deprecated. My personal position on this is that as long as a runtime is supported, it's fine for apps to keep using it. But certainly there are many apps kicking around which every year they roll onto an unsupported runtime, and having automation to update that would be a great start. And often they build cleanly, right? So you can just test and merge just like everything else. The second question I see is, can we use this tool to automate update GNOME/KDE tarball in manifest? The short answer is yes. In the specific case of GNOME, there is a GNOME-specific checker which knows how to contact the GNOME download server and parse an index which is on there of available versions of the components. It has some special handling for the odd-even numbering convention that GNOME has used prior to GNOME 40, and it has special handling of the .alpha, .beta, .rc convention that's used from GNOME 40 onwards. You can switch this off for components that don't follow that naming convention. If you want an example of this, the dfeat dbus inspector tool, which is on FlatHub, I recently updated that to use the GNOME checker to update itself. And that's a case where I had to disable the special handling of odd versions because it's version 0.3 point something. KDE, I don't believe there is a dedicated KDE checker. If there is some way to use one of the existing checkers to find new versions, then it can certainly be used. There's a checker which can scrape random HTML pages, and the JSON one is a pretty good starting point for checking for arbitrary components. For most pieces of software, there's a JSON file somewhere which tells you about it. So yes, you can. And please go ahead and do so. And if it's awkward, suggest ways to improve it.
So there is no any more questions. I think we just wrap up. We can wrap up the ahead of time now.
Okay. Thanks, everyone. Yeah, I had my email address was at the start of this deck. The project URL is here. I'm on IRC, many services. Yeah, please get in touch. I'd love to hear from you of how this tool works for you or how it doesn't work for you. Thanks.
Thank you. Yeah, everyone, please stay for the next talk.
All right. Thank you again, Will, for the presentation. Next on stage, we have Jan Beran and a talk entitled Making Flatbacks from Fedora RPMS. So welcome. To our attendees, please be reminded that if you want to ask a question to our speakers, you can do so from the shared notes on the interface.
Okay, hello, can you hear me?
Yes.
Great. So, hello everybody, my name is Jan Beran and I would like to tell you something about making Flatbacks from Fedora RPMs. So, here we have, great, we have an outline, what are we going to talk about? First of all, I will start with the introduction and what is a Flatpak and how does it work. Then I will move to Fedora Flatpaks and Fedora and Flatpaks. And then I will show you how you can build a Flatpak from Fedora RPM in a demonstration. And if we will have some time, I can tell you something about the future of Fedora Flatpaks. So, what is a Flatpak? I suppose everybody knows what is a traditional packaging system like RPM. You just make a spec file in case of RPM and specify everything like source code and where to install the files and these things. And when your application needs something, you just make a dependency to another package. And it makes a nice dependency tree. But this philosophy has some problems, or not problems, they are features, but it can be annoying. Like, for example, if you install one application, which can be quite small, it can have many dependencies and the dependency tree can be very huge. Of course, it's not a problem, it's a feature of a packaging system, but it can be a problem. But the second problem is that sometimes you can have problems with different versions of one package. Like, for example, if you need two applications and both applications depend on one package, but in different version, you can have one package in different version at one time in your operating system. So this problem can be solved, for example, by containers. When you make a container and install one application with its dependency in the container. But it's not very convenient process because you have to create the container, you have to install the application and switch between container and your host system. So we have, for example, Flatpak that can solve this problem. These dependencies, as I speak before, are divided into two groups. First group is called runtime. It's a big bundle of many libraries that are commonly used across a variety of applications. And of course, you can have more runtimes in your computer at one time. That means you can have, for example, a free desktop runtime, a Fedora runtime, and more runtimes. And this runtime is some base, we can call repository for dependencies. And if you install some application that is made as a Flatpak, it just targets specific runtime and uses libraries from this runtime. And that also means that when you can install a Flatpak on your operating system and you can install the runtime, you can install the application as well. That means the application does not target specific operating system, but specific runtime. But Of course, in the runtime there are no libraries, not all libraries. That's what I wanted to say, and that's not a problem because you can bundle some specific libraries with your application and make it one Flatpak, as you can see here. Can I? I can't. Anyway, so that means you can use a library from the runtime, and if there is no library that you need, or there is the library but in a wrong version, you can just bundle the right version of the library among your application and make it one package and ship it like that. So that's the philosophy of Flatpak. You just grab your application, grab specific libraries, make it one bundle, and that's it. And then on your host computer, there is already the runtime, and everything will go okay. Okay, so that's Flatpak in general. Now I switch to Fedora-specific Flatpaks and Flatpaks in Fedora. So why we want special Fedora Flatpaks? The one reason is diversity, because on FlatHub there are 1,200 applications. In Fedora repository, there are only 100 applications that are made in Flatpaks, but there are thousands more applications that are already packaged as RPMs. And we would like to pack these RPM applications into Flatpak and then ship them to practically any operating system. All operating systems that can use Flatpak will be able to use our Fedora Flatpaks as well. And that means they can use applications made as RPMs and converted to Flatpaks. So that's one reason. And the second reason is that, as we heard before, FlatHub Flatpaks are made directly from the source code. That's definitely not a bad approach, but in Fedora we have our RPMs, and there are spec files that tells you what files are installed where and why, and the process is very clear, and you know what's going on and how does it work, and that can be a benefit for someone. And of course, there is a as a user, you can choose if you can use FlatHub, Flatpaks, or Fedora ones. And this is the most important reason why we need, or why we want Fedora Flatpaks, because of Fedora Silverblue. I don't know if you know Fedora Silverblue, but it's a next generation operating system that is based on OS3 technology, which is something like Git for your operating system. That means the different versions of your operating system are like branches, and specific updates are commits in the branch. That's very cool, but it can have it has some problems. Like, for example, your /user directory is read-only. That means you cannot install RPMs, or you can install RPMs, but the process is quite it's not it is simple, but you have to create new OS3 commit and reboot your computer to be able to use that RPM. And it's not the preferred way how to install applications, because it can make problems when you switch to another version of your system. But we have two solutions for that. First of all, we have Toolbox, which is a great tool based on Podman. And you can create a container with Fedora workstation by 2 commands. And you can just create a container, enter it, and then use it as a normal Fedora workstation, but only in command line mode. This tool is intended to use and install terminal applications. But of course, you can install graphical applications as well, but the process is not very convenient. You have to create a container, you have to install the application via command line or terminal, and you have to run the application in terminal as well. And you cannot close the terminal while the application is running, of course. So for graphical applications, we use Flatbacks in Silverblue. And that's the reason why we need Fedora Flatbacks, because we want to use RPMs in Fedora Silverblue. And Flatpak is the tool, or Flatpak is the way how can we do that. So that's the reason. And we can switch to Fedora Flatpaks itself. I will tell you something about them, how do they work, and then I will show you a short demonstration. Okay, so what is Fedora Flatpak? As I said a million times, they are based on existing RPMs. And we are using Fedora modularity to make them. So if you choose to convert your application to from RPM to Flatpak, first you need to create a module, because we need to rebuild our RPMs with different prefix /app, because that's the place where Flatpak applications will live. And we cannot just grab everything from /user and move it to /app and expect everything will work. So we have to rebuild it. And why we use modularity is because we need to break the package space and be able to have a different version of that package built with this prefix. And once we have the module, we create an OCI container. FlatHub, Flatpaks are based on OS3, but we are using OCI images, which is simply a Docker container, because Fedora infrastructure handles Flatpaks in the same way how it handles server containers. It's convenient for the Fedora infrastructure that we use one tool or one process to two things. It's simpler. But it had some disadvantages, like, for example, with FlatHub applications, you could use Delta updates. It was a problem with OCI images, but I think it is already resolved, and you can use Delta updates with OCI images as well. And this process is based on two files, application.yml and container.yml. I will show you them and I will describe them. And registry Fedora project is just the place where Fedora Flatpaks live. So you can browse the website and see what applications are already converted. Okay, and now I'll try to switch to screen share. Okay, I hope you can see my terminal now. And as you can see, there are two files, supertux.yml and container.yml. I will demonstrate the process on supertux, which is a Mario-like game, but with tux. Okay, so we have these two files. I will open supertux.yml, which is basically a module MD file. which is auto-generated. I will show you the command how to do that. This summary, description, and license is taken from a spec file. Here in dependencies, you can see our Flatpak will target Flatpak runtime made by Fedora in version Fedora 34. And we are using also Flatpak common, which is special module which contains packages that are already rebuilt with /app prefix. It makes this supertools.yml smaller because if there is some package already converted with /app prefix, we can use it and we don't need to convert it once again. And here in the components RPM section, there is a list of RPMs that will be converted with /app prefix and will make the module. In case of supertools, there is only one RPM, and it is supertools itself. It's because supertools is simple and has no special dependencies. Everything it depends is in the runtime or your host system. For example, this can be interesting. This record means what branch will be used. So for now, we are using Fedora 34 branch, but we can use, for example, older one. In case a new version of the application is somehow broken or you just need the older one, you can just specify Fedora 33 branch and everything will work. Or, of course, you can target the latest version. I think it's not master anymore, it's main, maybe. And it should work too. I will stick with the latest version stable. And build order is just if you have more packages and there are some dependencies of dependencies, you need to build the dependency of the dependency first. So you can specify build order. But in our case, it doesn't matter. And now we can look at container.yml. It is automatically generated as well. The webcam is bad, but anyway. Yeah, so it's auto-generated, and for you as a developer, this is the most important part. Here in finish args, you say what permissions Flatpak will have, because by default there are no permissions and Flatpak cannot interact with your host system. It's safe, but it's useless because it just cannot do anything. So many applications need to interact with your monitor screen, so you have to add Wayland and Xorg socket. Then supertools is game, so there are some sounds, so you need audio socket, and for some reason we need a network connection for the game to work. For example, there are more portals, and we can also specify, for example, in case supertools would be some document manager, we can specify file system permissions. That means now supertools can see what is in my host file system. But of course, supertools is game, so it doesn't need it. And for example, here supertools needs to be renamed because appdata and desktop files are named supertools2.desktop, but we need to rename them to the ID name. So we just add rename appdata, rename desktop, and rename icon. Okay, I think that's all. And I will not switch back to slides because because the demonstration will be in terminal as well. So imagine you are a developer who maintains some RPM and wants to convert its RPM into Flatpak. So first of all, we need to create some directory with the name of the application. It's already done, called supertools, and we have to get these two files, container.yaml and supertools.yaml. It's done by a tool named fedmod. Sorry, I cannot type and speak at one time. Anyway, this command is for generating container.yaml and supertools.yaml, as I said. This just tells what are we going to do. Flatpak command says we will target Flatpak command. It's good because the resulting application.yaml will be smaller. And this last flag is interesting because there is no easy way how to determine what permissions your application will need. So we can use FlatHub manifest and just copy the permissions from FlatHub manifest. I will not run it because I already have these two files. And we should be in this state after that command. And now we can generate the module and container. It's done by a tool named Flatpak module. You can install it by typing sudo dnf flatpak module tools, install flatpak module tools. And this command will create the module locally, then create the container, and then we can install it. I switch back to the presentation. Yeah, this is only a backup in case screen sharing doesn't work. And yeah, this is what I was talking about. Yeah, and we are here. So now in my terminal, the module and container are built. It will take more or less 15 or 20 minutes. I don't know if we will wait, but anyway. So after performing step 1, you should have installed and running your Flatpak application, but it is local. That means it's good for testing and for checking if everything is okay. But I think you would like to make it public. So what to do? We need to request the repository, push everything to that, and build everything again, but this time in Fedora infrastructure. It's because Fedora infrastructure needs to check if everything is okay. Once the Flatpak is built in the infrastructure, we can test it, and in case everything is okay, we can submit a new package into body. And here you have the commands. First command is to request the repository, and the second one is to build a module and Flatpak in the infrastructure. I will not show it because it consumes a little time, a little more time that I have now. Okay, so these 3 steps are basically everything you need to perform to have your Flatpak application. So you can definitely make your own Flatpak application from RPM if you want, in case you are, for example, a maintainer of some RPM package. And the process should be quite easy, especially when your application has no dependencies or have only a small number of dependencies. So if you are interested, you can visit one of these links. First link is official Fedora packaging tutorial. The second one is a list of RPMs that are quite easy, and the process of conversion to Flatpak should be easy. So it's a good point where you can start and choose some easy application. And these 2 links below that are, it's basically the same I'm telling you here and now, but in a form of an article. The steps are a little more detailed, and that's it. But of course, if you have some questions, you can email me on the start of the presentation. I have my email address, so you can definitely write me an email and I can help. Generally, by now, the conversion is done only by a handful of people, but we would like to include community to the process as well. We would like to make creating RPMs and Flatpaks on the same level. And we are trying to, I can switch to dedicated slide to that. Here. We would like to integrate the community, as I said. It's because we would like RPM maintainers to be able to just run a few more commands and create the Flatpak application as well. And we are also going to automate the process because it should be quite easy to make it today, but the process still needs some manual work. And we would like to automate the process. So once the RPM gets updated, the process should trigger and everything should be I lost now. Should be automated. Sorry. As to the future, we would like to bring Flatpaks to RHEL as well, and we would like to make Flatpaks from corporate repositories. Okay, that's it. And I think I skipped something. Yeah, the process itself should be quite easy, but sometimes you can run into some troubles, like, for example, generally speaking, most of the problems with conversion RPM to Flatpak is done by spec files that are not compliant to our guidelines, and some things are done in a special way, and it breaks the process. But in case you have only 5 to 10 dependencies, it should be okay. Okay, and for ones of you who would like to try our Flatpaks, Fedora Flatpaks, this command should activate our Fedora Flatpak repository, and you should be able to install Fedora Flatpaks on your system. And that's pretty much it. I will switch back to screen share and show you the second part of the demonstration. Okay, so as you can see, the build process is still running, but I can do a little magic, and voila, we have OCI image already built. It's because I have done it before my presentation. Anyway, this state is somewhere after step 1. So now we need to install the OCI image and test it. It's just done by Flatpak module install and that OCI image, and it should install after a short time. Anyway, okay, it does. My hard drive is full. Oh, okay. So anyway, in case you don't have a small SSD disk, it should pass and everything should be okay. So check your free space. Anyway, in case everything goes okay, we would have installed our SuperTux application, and everything should be okay. I think it's not necessary to clean my disk now and show you the SuperTux application. You can convert it by yourself and try it. Okay, so that's pretty much everything I wanted to say. And if you have some questions, you can ask.
Thank you very much for your presentation. It was pretty interesting. There are actually a lot of questions in the shared notes. I'm not sure if you can access them. I can read them for you if you prefer. As more convenient for you.
I can read them myself.
Okay.
So first question, isn't this a fragmentation risk? Yeah, I suppose this question is intended to... I will switch to the right slide. Yeah, here, there can be 2 libraries in the same version. For example, is this application, we can call it 1, has some library in version 1 because it's not in the runtime, and here the application 2 has the same library. Yeah, in your system will be 2 libraries in the same version, but private for 1 application. Yeah, it can bring a little. First of all, it will consume a little more disk space, but after years of using Flatpak, you will see it's not that much. So I hope I answered your question. And the second one is, why is it necessary to list the RPMs? Can this be determined by looking at the app's dependencies, then subtracting the packages which are included in the SDK runtime? In fact, it is determined by this way. I will switch to off by 1 here. This list of the dependencies is mainly for you to see what is present and what is not present. Sometimes it can happen that the package has a broken dependency. There is something that is not needed, and you will figure it out that you check this. And the opposite situation is that your application depends on something which is not in the RPM, and here you can check. But it's generated automatically, so it's not a work for you. So that was the second question. And the third one, what is the difference between Fedora runtime and other runtimes? Basically, the biggest difference is that Fedora runtime is done by is made from RPMs. But generally speaking, the function is the same. And it targets specifically these special Fedora Flatbacks. Okay, I hope I answered the third question. The fourth one is, are there any downsides to packages built this way? If you mean generally Flatbacks, there are downsides, as I said before, that you can have two libraries in the same version but made private for application 1 and 2, for example, and it can be a little more risk to the security because it needs to be updated. But in Fedora, because how to say that? If this happens, if you have one library of some version bundled with two applications, it origins from the same RPM, so it doesn't matter in Fedora Flatbacks. In case of FlatHub ones, you need to wait until two maintainers will update their manifests. I hope I say it correctly, because I'm primarily a Fedora Flatpacker, so I'm not entirely sure about FlatHub. Okay, that was answer for the fourth question. And the fifth one. Can the container specify what architecture to be used? A few projects are ARM only for now, as an example. Actually, I'm not entirely sure. I'm not sure. Sorry. Yeah, so I cannot answer. So that was no answer for number 5. And the sixth one. So the plan is that a maintainer needs to ask his users, but which version of my app are you using? I'm not entirely sure what is the question about. Somebody's adding some info, so I'm waiting. Now I understand the question. So the new question is, so the plan is that a maintainer needs to ask his users, but which version of my app are you using? This means that the developers won't know which binaries of their application are being used, either theirs or the ones I create. It depends on the situation. Like, for example, if you report a bug and you are using a Flatpak application, you should target this bug to the Flatpak of the application. And in case it's a problem with Flatpak, it will be repaired or fixed on that level. And if it is an upstream problem, it will be solved upstream. I think the process will be similar to RPMs. Like if you have something with RPM, you target your bug to that RPM, and if it is an upstream problem, it will be forwarded to the upstream. I hope I understood the question correctly and answered you. And that was the last question. So I hope I answered everything correctly, and if it's everything, I think that's it from me.
Thank you very much for the presentation. So if anyone else has questions, please use the shared note. We'll just wait a few seconds, I guess, just in case someone wants to add something in the questions. If not, big round of applause, great presentation. We'll now have a little bit of a break, and we'll see you back at 11 UTC time for more great talks. So thank you everyone for joining us this morning, and see you later. Welcome back, everyone. We hope you enjoyed the break and you managed to get some relax and to rewind maybe some of the talk we had this morning. So next on stage, we have Igor Ivancic, which is talk about 15 cool things you didn't know you could do with snaps. So the stage is yours. As before, if you have questions, feel free to use the shared notes so that we can read them at the end of the presentation.
Great, thank you. Hello, everyone, and welcome. First, a quick question. Does my audio come through well, and is my sound volume reasonable? No echo, no feedback. I hope you can hear me well.
Sounds great.
Excellent, thank you. I will take control of the sharing screen so I can present and control the slides. So give me 1 second, please. Okay. So I've now switched the slides. I think you can see this. Welcome to the presentation. My name is Igor, impossible last name. I work at Canonical. I'm a developer advocate at on the Snapcraft team. And today I want to talk to you about some interesting things that can help your life, either as a developer or an end user. So, okay. I will stop sharing my screen and I will control the slides using the built-in feature. So I just have to figure out how to move slides. Okay, excellent. Sweet. Thank you. So back to the presentation. Thank you, Alison, for that. Back to the presentation. So I want to talk to you about some interesting things that will help you use snaps either as a developer or as an end user. You may know some of these things, so apologies in advance if things look familiar. The other thing to take into account is if I move through some of the topics quickly and you have questions, please ask them. Also, all of the stuff that I'm going to review is documented on our documentation, and I have written blog posts about most of these topics in detail with examples. That said, a little more about myself. As I said, I work as a developer advocate. I've been using Linux for roughly 2 decades now, doing it for fun, for passion, and work. I happen to write books. That is my second big passion. And the third one, as you can probably guess, looking at the image, is I like to drive fast cars on racetracks around the world. The COVID situation has made that a bit more complicated, but I'm trying my best. That said, let's go with the first trick. So when you develop snaps, you have 2 options to use different backends for development. Basically, snaps will be built inside contained environments so that you don't pollute or change your underlying system on which you build. You have 2 options. You can use virtual machines with Multipass as the driving engine, or you can use lightweight containers with LXD as the driving engine. If you have a virtualized environment yourself in which you develop, you may find it a little bit more difficult to use Multipass due to potential nesting. To work around this, you can use LXD with a special switch, which allows you then to build snaps inside virtual machines. So we have an inception situation, basically, a virtual machine, container inside a virtual machine. And of course, you can try to see how deep you can go before the system explodes. Remote build. This has been brought up yesterday during our office hour. And the question was, is it possible to cross-compile snaps? The answer is no, but. And the but is the option to actually use remote build functionality. You can send your project to Launchpad, and Launchpad will build for 6 different architectures, which you may not have necessarily locally. You basically need just your Launchpad token to authenticate, and after that, your project will be built. This is quite useful if you want to target, say, ARM, or you want to target something like IBM S390, or other things that you may not necessarily have in your architecture portfolio. Of course, you still need to test your snaps. You have to make sure that the libraries you have selected and that your application logic can function on these other architectures, but this can greatly simplify your work. The one caveat is that your project will be public in the sense that it will be available and visible on Launchpad. So if you have a closed source application, you probably shouldn't use this. Okay, shell after. If you're developing a snap and you want to see how it behaves after it's been built, you can use shell after to step into the snap build environment world and see what happens there. This way, you will have access to snap environment variables. You will have access to the build structure and be able to inspect different bits and pieces. This can be quite useful if you're trying to troubleshoot an error that doesn't seem obvious from outside of the build environment. So you're building, something goes wrong, you're not quite sure why things are misbehaving, step into the build world and troubleshoot yourself. Then you can, of course, step out and resume your normal development work. Tip number 4 is, again, something that should help you build your snaps much faster and test them more efficiently. So you can actually test a snap without installing it. For example, just download a snap from the store, then unsquash the archive. Snap is basically a squashfs file system archive. Step into it and then run snap try. This will emulate the normal installation of a snap, and it will be presented to you as an installed application, which you can then try and play with. So at this point, you could potentially add things into the squashfs file system, and then snap try again, basically remount the archive, use it, see what gives. And this can help you, for instance, nail down any missing libraries, figure out if you have any permissions or broken symlinks, perhaps. Things that could potentially happen if you have maybe some disorder in your sources. Similarly, you can use snapcraft back. If you have your sources and if you have your built artifacts in a work folder, in a work directory, you haven't yet built the snap itself, you can use snapcraft back, which will assemble all these different components into a snap, and then you can try it and play with it. Both these things should help you work faster, as in you don't have to wait for the build environment to be built. You don't have to wait for long compilation times if you know that the problem is in just small bits and pieces just before the runtime of the application or something similar to that. One more thing that should be useful to developers is Snappy Debug. Basically, if your snap doesn't run well, and this can happen due to permission errors, as snaps are self-contained and confined applications, and they communicate with the underlying system through a mechanism of interfaces. So if you haven't specified the necessary interfaces, or they are not connected, or perhaps there are other permission issues due to the nature of this confinement, you can then install a special troubleshooting snap called Snappy Debug, run it in a separate command line window, and as you run your snap and test it normally in a different terminal, in a different shell, you will see a log, an output in the Snappy Debug log. It will give you AppArmor denial errors and suggestions on how you can work around potential problems. This can help you understand why, even though the build may be successful, your snap doesn't run well, quite as well as it should. Again, for developers and people interested in understanding how and why things work, there's Snap strace. Basically, strace is a utility that lets you trace system calls and understand why and how problems may occur during application startups or runtimes. You could have a crash and you need to understand why something went wrong. So you can run snaps with an strace flag and then use all the normal optional arguments that strace supports to print out the log of that execution. For instance, you may only want to trace open system calls, or you may actually want to have longer printouts, so the default 64 character string may not be sufficient for you. You can also do just the summary of the run and understand what's happening. This is quite useful because it allows you to step into the snap world despite the fact that there is strong security confinement around it. And warming up, on the same note, we also have GDB support with snaps. You can actually run a GDB server, which will then open a high port, and connect to it using either a different terminal window or even an IDE or any remote debugging troubleshooting tool that supports GDB. And so in a separate shell, you run GDB, and then you can do the usual things that you would do when you're troubleshooting an application. You can set breakpoints, you can set conditions, you can step into the execution, you can disassemble the code. So everything that you would normally do to understand if your application is not working, you can also do with snaps. Review tools. So let's assume that you have built your snap, you've tried all the other different tricks that we've just outlined, and you believe that your snap is ready to be uploaded to the store. Normally what happens is your snap will be reviewed, it will be automatically scanned, and it may not be allowed into the store just yet for publication if the security scan detects potential problems with your application. For instance, you may have broken security permissions, or your application tries to do something that it shouldn't. You will get these errors, and then your upload will be blocked. Basically, your publication will be blocked until there is a manual review by the security team. To minimize this time disruption, you can run review tools, a lightweight version of what happens when you upload your snap to the store locally. Install it, run it, and examine your snap. It will give you indications, warnings, or hard errors as to what you may have done wrong security-wise, so you can go back, fix it, get a green light from review tools, and only then upload the snap. Should save you time. Apologies. Should save you time, especially if you're in a hurry and you want to upload your snap and publish it quickly. Default track. Most people will probably just have one track, one main, let's call it, one main path to how they publish their snap. And some people may actually have multiple tracks. And you may have a legacy track, for instance. You may have the latest track. The latest track is the default one. You may have a numbered version tracks for your application. But then you may want your users not necessarily to use the last or the legacy track. You can set actually which track is the default one. So when people install without additional arguments, they will get the desired version. This can actually also help you perhaps test how your different versions behave, or maybe stagger the installation of different versions of your application. It's entirely up to you. But the option is there and you can use it. Snap connections. So earlier, I mentioned security confinement, and I mentioned interfaces. So to give it a more visual analogy, snaps are fully self-contained. So they sit in a benevolent prison, and they can't communicate with the outside world. That's a security feature by design. But then snaps that don't communicate with system resources aren't that useful. Therefore, there's the mechanism of interfaces. You can tell snaps to be able to connect to the home directory, to network, to the audio and video, perhaps Bluetooth, USB. There are tons and tons of interfaces. Some of these will be auto-connected, which means when the snap is installed, they'll be available to the end user. Others will not. And if you want to make sure that your application works and behaves as you expect, you can check for an installed snap which interfaces it has connected. Basically, which plugs and which slots those plugs connect into. And if a certain interface isn't auto-connected, then your application may assume behavior that is not available and may not run well. Similarly, as an end user, you may want to test the snap, but you're not quite sure what it does. So you could say, okay, I will disconnect the snap from network, for instance. I want to use an Office suite just in an offline mode. Or maybe I want to use the browser, but I don't want to give it access to audio or my webcam. So you can tweak your privacy opportunistically as you need to. You can perhaps disconnect the browser during the session, a specific interface for a browser during the session, then you can connect it later on, and vice versa. Aliases. So this is something that can be useful if your application if your snap has multiple applications contained inside it, or you want to make life easier either for yourself or for your end users. Normally, snaps have one application inside. So let's say, for instance, I'll just use a silly example. Let's say kcalc, a calculator, it has one application inside it. It's just the calculator itself. But if you look at something more complicated, let's say LibreOffice or Calligra, you have multiple applications. You have the spreadsheet application, you have the word processor application, you have the presentation one. So there can be 3, 4, 5, 10 different applications contained inside a snap. So when you run that snap, you then need to invoke the specific application explicitly. You have to give a full name and then the application name. And in some cases, this could be a bit cumbersome. Then if you want to make it simpler for your users, you can request from the store team to create aliases for you, or as an end user, you can create them locally on your system. And then, for instance, instead of executing, let's say, LibreOffice.writer to run writer, you could just have writer as your alias or something completely different, whatever you feel like. This can simplify usage and make the overall experience more streamlined. Parallel installs. I think this is probably one of the nicest end user features that exist, and one of the great advantages of snaps compared to the traditional Linux packaging. You can have multiple versions of the same snap installed on your system. And in some cases, you may even be able to run multiple versions of the same application in parallel. The way this is done is you may potentially need to enable an experimental feature on your system if it's not enabled or supported. And then you can install a snap by giving it the name it has in the store, and then underscore as a qualifier that defines the versioning, and then give it whatever string you like as a version name. So for instance, we have a screenshot here of VLC. You can install VLC first, VLC second, VLC fifth, whatever you like. And then these multiple snaps will be presented on your system in parallel. And then you can run the first instance and the second and the third and the fourth. And you can perhaps compare how they behave. I here have a screenshot where you have the current VLC3 family and then the new VLC4 sitting side by side. And you can see, oh, I like the new UI, I don't like it, I want to compare functionality, is the audio quality the same, and so forth. Please know that in some cases, your application itself may not like having multiple instances of itself loaded into memory. An application may bind to a port, may use sockets, may expect to use a data profile from your hard disk. And if multiple instances try to access these same resources at the same time, you could have a contention or a potential conflict. So in some cases, this may not work from the pure application functionality aspect, but in others, it may work really well. And even if you can't really run things at the same time, you can have them definitely installed in parallel and then test them in a different way. These don't have to be just major version differences. These could be different stability levels that are available in the store. You can have a stable version and an edge version side by side, compare them, see how they behave. Is there any breakage in functionality? Is everything working the way you expected? You want to migrate to a new version of a tool? Are your databases going to be affected? Is your usage pattern going to be affected? It's quite useful. Okay. Now, a little bit of housekeeping. So today, people have pretty big hard disks normally, and space isn't an issue. But sometimes, especially for laptop users, storage can still be a bit of a problem. If you have SSD or NVMe storage, they usually come at a higher price. So you won't necessarily have 2 or 4 or 8 terabyte SSD. You'll probably have something smaller. And in that case, you may want to kind of make sure that your disk usage is reasonable. By default, when you install snaps, 3 revisions will be kept. So you install revision 1, 2, and 3. The pointer will rotate to the latest version and you will be using it, but the others will still exist on your disk and take space. You can actually tell Snapd, the service that manages this, how many versions you want to retain. The minimum is actually 2, but you can go up as much as you like. And this could be useful if you have, I don't know, if you need to have these multiple versions for legacy purposes, for testing purposes, to keep track, nostalgia's sake, whatever you like. This way you can trim down overall usage of how much snaps take, at the very least if you want to trim it down by about a third. I will stop briefly to answer a question about the previous point which I brought up. I'll go back. It's, do parallel installations isolate instance app configurations? If I understand correctly, this question is, does each snap run data isolated from the others? And the answer is maybe. So, of course, some data will be private, but there will be some shared data. Let's think of something like a browser profile. Your browser profile is one, and it sits on the disk, right? So if you load your browser profile and you want to load it into 2 different instances of an application, that may work or may not work. The problem is mostly with writing, right? If you do 2 separate browsing sessions and then you need to write the session to the disk, which one takes precedence? A separate one would be your application may listen on a local port, let's say 9500. Both versions cannot bind to the same port at the same time. You might have to edit configuration and say, okay, this version goes to port 9500, the other one will go 501. Those kind of things. So it is a combination of what snaps can do, but also what the application can do. Worst case, you will have these parallel instances, but you may need to run them sequentially. However, you still have the option to do that. Running parallel instances in parallel applications on your disk, that may or may not work always. That's a bit of a hit and miss. So back to the snap revisions. Like I said, we can, by this way, you can trim down the data usage by about a third, or of course increase it if you have a need for that. On the maintenance side, there's also an important element of snap updates. So snap refresh occasionally. By default, Snapd will contact the store 4 times a day and ask for any updates to your installed snaps. If those updates exist, your snaps will be updated. In some cases, this may not be convenient. You may be presenting, like I'm doing now. You don't necessarily want to have an update happening in the background for, it could be disk usage, it could be network usage, or you just don't want an application to update while you're working with it. You may also have a specific environment requirement. Say at your workplace, you don't install applications on every system at the same time. You have a staggered deployment. You install on 4 or 5 test machines first, then you have a kind of a semi-staging area, and then finally you have a production setup. So you can modify when the Snapd service runs its updates. There are multiple options. First of all, you can set almost like a cron, a specific timetable. You can say that updates only happen on Friday at 2 o'clock. You could also say that snaps only update every second Tuesday. Or you can go with a very specific date format, which you can set and then convert to tell Snapd, okay, I'd like my snaps to update on the 27th of May at 9:24 in the morning. This way, you can then combine updates, which bring security and functionality changes, with testing, reliability practices, or other things that you may have in your business organization or even at home. In general, you can defer snap updates up to 60 days at the moment. this may change in the future, as in you may get additional further controls and flexibility in how this is done. And there is a question here where it says, will it be possible to configure refreshing from the store GUI or the updates app or the repositories to make it more friendly for newbies? The answer is perhaps. So one thing to take into account is that people don't necessarily just use Ubuntu. They may be on a Fedora system or Arch, Manjaro, or OpenSUSE, and their front end will be different. So in some cases, the implementation will rely on the specific distro implementation, whether it allows and supports snaps in the backend. If that exists, it might be implementable. Whether this should be available through a front end, like say Gnome software on your Ubuntu system, maybe it's a double-edged sword, because on one hand, if you are a newbie, you might not necessarily want to tinker with updates because you don't necessarily understand the full implications of such changes. If you are a more tech-savvy user, then you will have 15 workarounds to every problem and 5 solutions as well, and then you will feel comfortable doing it. It is very difficult to balance these kind of things, because normally what you end up is either an oversimplified solution that makes techies super angry, or you end up with super techie solutions that newbies cannot use. Technology, in a way, if you look at the two sides of the spectrum, you either have something that's very, very simplified, like you have on smartphones today, in a way, or you have Linux, where it's basically do it yourself. And then what's the best solution? For mid-range users, it's hard to say. Please email me. You'll see my email at the end of this presentation. I'll bring it up with the Snapd team, and we consider all proposals, ideas, and suggestions. Doesn't mean we implement all of them, but we'll definitely look at it. And if you have a real need, and there's a way for us to implement it in a reasonable way, I don't think there should be a big problem with it. Okay, so snap refresh control, you can do basically whatever you like, well, within reason. And I think this can be especially useful if you have a critical application that consumes a snap. So you can then say, all right, I have 4 systems. The first system will get its updates daily. The second system will do it only weekly. The third one will have a monthly update with rigorous QA. And the fourth one, a production system, only if the first 3 checks pass, we deploy. And then that one will have, say, a deferral of 60 days. And every time you successfully update your snap, you will then push the date for next update by another 60 days. That's just an example. Or you somehow combine it with your configuration management tools, Puppet, Chef, or so and so forth. Number 15, this will be the last trick of the day, is snapshots. I added a lightweight joke here for you to practice at home after the session. Basically, you can snapshot your snaps, and snaps get snapshotted automatically when they get removed. Have a snap on your system and you don't want it anymore, you delete it. And then 2 days later you say, oh, I didn't back up my data that was contained in that snap, it will be gone, right? To avoid that painful situation where things are forever deleted and any trace of it is lost from your disk, Snapd will keep a snapshot of a deleted snap for 30 days. You can, again, manually, yes. The question number 3 is, can we force snapshot? Yes, you can. You can just run snap save, name of a snap, and you will have a snapshot on your disk. Of course, this takes space. Snapshot is basically just an archive. You can copy it then and extract it to a different system if you like. If you want to have your own data retention or reinstallation policy, you could technically have a script that snapshots your snaps. You can then SCP or rsync that data to a second system, for instance, extract the data from the snapshotted archives into the snap writable directories, and you will have the data available for use. In some cases, if your application has system or machine-specific information saved, then you could potentially encounter weird things when you restore these snapshots on a different system. Let's say that your application relies on a machine UUID or a hardware model for some reason, a string of a hardware model, something, whatever, right? If you then restore on a system that doesn't have those specifications, your application may go, oh, wait, I'm using data that doesn't really belong to me. But in general, you can create snapshots whenever you like. You can check them. You can delete them. You can also delete snapshots that are created for your deleted snaps. If you feel like, okay, I don't want this, I really want my disk space back, you can just purge any snapshot with the full knowledge that your data will be gone, of course, inside those snapshots. And I think this brings me to questions and my contact details. So if you want to ask any questions around snaps or even any other things, feel free to reach out. If I don't have the answer, I'll direct you to the right person in Canonical. We have about 10 minutes, if I'm not mistaken, and feel free to ask any questions that haven't been raised so far. Okay. We have, yes, please. Okay. So we have two questions. I'll answer number 5 first because it was typed down first. Is what will happen if different users install the same snap? Will different snaps be installed? I presume the question is, it's the same system, a multi-user system, which has 2, 3, 4 users running on it, and they all have admin privileges to install applications. Am I correct in this assumption? So snaps are installed globally. So you can't really, you can parallel install multiple versions, but if you install the snap, it's there. So you won't necessarily have a problem where you have multiple namespace. You don't have multiple namespaces. There's one namespace. So that shouldn't be a big issue. However, if you have multiple admins, they could potentially install multiple parallel versions of a snap. They could tweak configurations, or they could do things with system management that could conflict what the other user has in mind. When it comes to admin, I think it's like in the movie Highlander. There should be only one. So hopefully you have seen the movie and remember it. So otherwise my joke is waste here. And number 4, does Debian also have such system feature? Can you please clarify what you mean by such system feature? I'm not 100% sure which one it is. We have 15 things that I've mentioned. So is this related to snapshots? Okay. Does Debian have snapshotting functionality on its own? To the best of my knowledge, no. Most Linux distributions don't have that because the file system isn't layered. Everything is basically shared. Some operating systems do have this. For instance, OpenSUSE, if you use ButterFS, has a tool called Snapper, which allows you to create ButterFS snapshots, and then you have the ability to delta your system changes. And if you don't like something, you can then restore a previous version, I think even through the boot menu. If there are any OpenSUSE users who have used ButterFS and Snapper, you can maybe help out and add additional information here. Most distros and most systems, Linux systems, don't have snapshot features. You can implement your own mechanism with something like timeshift, or you can use system imaging, or you can just use rsync and create your own archives. So whoever asked number 4, I hope this answers your question. Thank you. Number 6. Can you use the home interface to give each snap its own home directory, mapping to an arbitrary location in the file system? Snaps don't necessarily have access to arbitrary locations because of the security confinement. There is a confinement mode called Classic, which gives you system level permissions. That one has arbitrary access to the system, and it's necessary in some cases, like for instance IDEs, which need to access data in random places or even trigger arbitrary binaries. Strictly confined snaps are not designed to wander around the system and touch things that they don't belong to them. So snaps, yes, they can have their own data repositories or their own mini homes, but then they need to be implemented in the application logic. You could potentially say to your snap could then write its configuration into a specific subdirectory or use a specific hidden file that can also be agreed upon from a security's perspective with a store team. But there's also an element of application logic. It cannot be just a blind snap side change. The actual content of the snap also needs to be location aware in that sense. Otherwise, if you just use something like documents or pictures, it will assume it's the documents and pictures that are available through your home directory. Any other questions? Okay, question number 7. What containerization tools are used in Snap? Example, bubble wrap in Flatpak. So the security confinement is done through multiple tools. There's AppArmor rules, there's seccomp, and cgroups. Those three give you pretty much the isolation from the underlying system. You can actually inspect this. If you have a Snap system with snapd, go under var snap and start exploring, and you will see some rather interesting things. Or if you are code savvy and you really want to know the internal mechanisms of the snapd service, it's available on GitHub. Source is there. You can poke around and see what gives. Even compile your own version if you like. Questions for us? We can also do a live practice of that funny sentence that I wrote in slide number 15, is how many snaps could a snapshot, if snap could snapshot snaps, and the winner gets, I don't know, I'll leave it to the organizers of the conference to do it. So yes, question number 8. What's the status of Snap support across distros? Officially, snapd can be installed and used on 40 plus distributions, including the Debian family, Ubuntu family, Fedora, Red Hat CentOS, Arch, Manjaro, and a few others. So if you are a user of one of the supported distributions, snapd should run well, your snaps should run well, or just as well as they run on an Ubuntu system. If they don't, then we may have a problem with our tooling, and if we would definitely like to know about it so we can help improve and make your user experience just as good as it is on, say, on Ubuntu. I mentioned this briefly in the office hours. For instance, in our engineering teams, we use different systems. We have a couple of people with Arch. I myself use Kubuntu, so I have KDE. We have people who are on the latest version, people who use latest LTS, people who use the latest interim release, people who are on the previous LTS, we do try to vary a little bit so that we don't just test one thing and say, okay, if it works on Ubuntu, that's perfect. We also try to make sure that other distributions are first-class citizens and that everyone has the same consistent experience. If that's not the case, we would actually urge you to tell us so we can make it better. Number 9 isn't so much a question, it's more of a comment. Nobody uses Fedora on the team. Okay, it's a nice joke, I'll allow it. I hope this is not Alesh being funny again, because he ran out of his jokes quota yesterday. Any other questions? Any other questions? Here's a super interesting question. Number 10, other distributions basis for snaps possible. I presume you are talking about, okay, so for people who don't understand what this question is about, because snaps run in an isolated manner, they need to see some sort of a root file system. So basically, the file system that is presented is something called base, and it is equivalent to the Ubuntu LTS release based on the versioning. So if you have something like Core 18, then your underlying system, your base will be Ubuntu 18.04. If it's Core 20, it will be 20.04 and so forth. But the question is then, can we perhaps have something like a Fedora core or maybe CentOS core or something like that? Technically, yes. Has that been implemented? Not to the best of my knowledge. But if that can drive Snap adoption or make the user experiences even better, I think this is worth exploring, maybe even working together. So whoever asked this question, please reach out. Maybe we can explore this and make this a possibility. Sweet, free desktop SDK. Sounds good, sounds interesting. Can you please reach out? Thank you very much. This is, I really like this, and I want to see how we can explore and make this maybe into a real possibility. Number 11, what's your favorite experimental feature? I have to say parallel installs, hands down. It is so good, because typically if you want to have something that's parallel-like on Linux, you download an archive from a vendor. If they offer their Linux application as an archive, you unzip the thing, and then you just run it locally. And this way you basically have a normal application. It's available to the system menu. You can have 400 instances of it if you like, and you can do crazy things. So I recommend you test it and club your system with multiple versions of application, just to see what gives. 12, do you know if there's some chance of Fedora Silverblue supporting snaps? I think that question should be partially answered by the Fedora team. I don't know if we have anyone here, I don't know, who works on Fedora. And if they are here, I welcome them to answer this. Or even if you want, you can reach out by email, and we'll see and see how we can explore this potential. We have 3 minutes. So if there are any more questions, please let's try to give, let's see if I can answer that in the next 3 minutes. No more jokes from Alesh. Number 13, how can we make sure developers update dependencies for security? Okay. First, on the Snap Store side, if you're a publisher and you have an account in the Snap Store, you will get email notifications that your snaps have out-of-date security packages. At that point, it is your due diligence as the publisher and the developer of that snap to update it. However, there is always an element of human goodwill and application supportability on behalf of the developers. So it's a two-way thing. One, we try to expose and make potential security issues visible to the publishers and developers, and help them update their applications in a smooth manner. But then there also has to be goodwill and desire from the publishers and maintainers and developers to keep their applications up to date. So that will never be a complete solution without cooperation on both sides. Okay, let's see what else is here. So there's one more comment on question number 12, whereby classic snaps use /snap, which is forbidden by RPM OS 3. Regular confined snaps work fine. I understand. Classic confinement is never really a one-for-all solution. But since this is a very interesting topic, please reach out, because there might be something in the works that we could think of and figure out how to fix this. And I think I'm out of time, and I need to hand over to the next presenter. So please reach out to my email for any other questions. I enjoyed the session today. I would have loved to hear you, because I enjoy human interaction. If you have any other comments or jokes, please reach out. If you like this session, give a thumbs up as well. That works. Hope to see you around. And if you need any help with Snap development, just knock on the door and we'll see what we can do together. Thank you very much for your time.
Thank you very much, Igor, for your presentation. It was really, really good. And also thanks for taking time to reply to all the questions. There was an interesting Q&A.
Yes.
So next, we will have 3 lightning talks. So while we set this up for the next speaker, also thanks everyone for posting questions in the shared notes. So next we will have Henning Grund and a talk on Qt Design Studio on closing the gap between designers and developers. So give us 1 second to set this up, and we can start with the lightning talks.
Hello, my name is Henning Gründel and I'm a senior software engineer at the Qt company working on Qt Design Studio, our tool for creating next-generation UI and UX design. Today I want to tell you about Qt and Qt Design Studio and how they improve the application development process for designers and developers, followed up by a short demo and a Q&A session. Let's start with a brief introduction to Qt. Qt is an open-source, cross-platform application and UI framework based on C++, with tools designed to streamline the creation of applications and user interfaces for desktop, embedded, and mobile platforms. The framework consists of various modules belonging either to Qt Essentials, which define the foundation of Qt, or Qt add-ons, which bring additional value for specific purposes. The two important modules for UI development are Qt Widgets, which provides a library of UI elements that allow to create classic desktop-style user interfaces, and Qt Quick, which is the standard library for writing QML applications. While the Qt QML module provides the QML engine and language infrastructure, the Qt Quick module provides both a QML API, which supplies QML types necessary for creating user interfaces, and a C++ API for extending QML applications with C++ code. You can use Qt's IDE, Qt Creator, to write C++ code, and its design tool Qt Design Studio to create UIs based on QML and Qt Quick. People who developed KDE software before are probably already familiar with the Qt framework. So what's Qt Design Studio? Qt Design Studio is a full-featured design software for creating user interfaces and user experiences using QML, aimed at designers and artists who are working with both 2D and 3D content, scaling from low-end hardware devices such as MCU to large-scale 3D desktop environments, and of course with Qt's cross-platform capabilities to deploy your design to any operating system, mobile or embedded device. Qt Design Studio is a Qt Creator adjusted and optimized for designing QML and Qt Quick, and is available as a commercial and free community version. So what can you do with Qt Design Studio? You can create screen designs and layouts using a What You See is What You Get editor with a selection of powerful native Qt Quick components and libraries. It also allows you to create animations using our timeline, define UI logic with states and bindings, and create custom controls only using the UI of Qt Design Studio. The commercial version of Qt Design Studio comes with so-called bridges. Those can import 2D-based designs from powerful UI design tools like Figma, Sketch, and Photoshop. This makes it easy to import your assets. It is also possible to import assets from 3D tools like Maya, Blender, or even 3D Max into Qt Design Studio. Those designs and assets will result in a working QML application that you can deploy, run, and even profile. These are only a few of the features available with Qt Design Studio. In the following demo, I'll try to showcase some of them. So let's go ahead and open Qt Design Studio. We start by creating a new Qt Quick application via our project wizard. Now that our project was created, we can see the visual 2D editor in the center showing our default application. On the right we can see the property editor, which shows the properties of the currently selected item. Let's select the text item and make it a bit bigger. For a proper UI we need some buttons, so let's drag them in from the item library located on the left. Let's put them in a row layout so they align nicely, anchor the layout horizontally, and increase the spacing between the buttons. To add some logic to the buttons, let's make them checkable and exclusive, so only one button can be checked at a time. We can have a look at the current state of our application by opening the live preview. While the live preview is open, changes made in the application will be reflected directly. Now let's create some additional states via the states editor located at the bottom and connect them to the button's check property. By default, you will always have a base state containing all the items in the scene. Let's modify the additional states so they will differ from our base state. By using the binding editor, we can bind the check property of our button to the when condition of a state. Now the state changes according to the currently checked button. Selecting the Text Editor tab, we can see all the QML code that was written for us. There is the root rectangle containing the text item, the row layout containing the buttons, and our states we've created. By adding transitions via the transition editor, also located at the bottom, we can get rid of the sudden color changes when switching between the states. This is already way better. We can also change the transition behavior by adjusting the easing curve using our easing curve editor. Next up, we add a slider and a rectangle. Let's add a second rectangle as a child of the first one. This will be used as an indicator. We want to change the scale and rotation of the rectangle according to the slider's value. Binding the slider value to the scale property works perfectly. But to cover the full rotation from 0 to 360 degrees, we need a range mapper as the slider value ranges from 0 to 1. In order to make this work, we need to bind the slider value to the input of a range mapper, change the range mapper's input and output range, and then bind the range mapper's output to the rectangle's rotation. Let's have a final look on our demo we've created. This short demo is only scratching the surface of Qt Design Studio's full potential. More sophisticated examples and tutorials can be found on Qt Design Studio's welcome page. To give you a glimpse of what is possible with Qt Design Studio, I'll quickly show you our digital cluster demo. Here you can get an impression of a lot of the features like 2D, 3D, animations, transitions, states, bindings, and imported assets in a proper scenario. With this demo, I want to conclude my talk. Thank you. Hello.
Hi, everyone. Sorry for the little hiccup of technical difficulties. I know we are into Carl's time, and both Carl and Henning, you have the ability to update your audio. If there's any questions from the previous talk, this Henning's talk, please add them in the shared notes. I hope everyone was able to view the video okay. And if there are no questions, I'd love to introduce Carl Schwann from KDE, talking about behind KDE documentation tooling. Carl, you are muted and we cannot see you. Just a heads up.
Yes, does it work now?
Yes.
Okay.
Yes, thank you.
So hello everyone. Today I will present you a bit of an overview of the KDE documentation tooling for technical documentation. But first, who I am. I'm a KDE developer since 2018. I'm mostly focused on developing websites, for example, the KDE.org websites or the new fundraiser website for Twitter. But I'm also very involved into the mobile application, for example, Node.js, the Matisse client, Tocodon Mastodon client, Contrast Checker application, Coco Image Viewer, and Colibri mail application. But first, why should we care about documentation? There's a popular memes about what code is documentation enough, but I don't really agree with it because it's often not enough, and for newcomers, it's having a good documentation is great, and making it easy for newcomers to get started to increase adoption of the library. But it's also very useful for experimental developers because even if you work a lot with libraries, we don't necessarily know everything about it. So it's documentation is an important part of how to build an app ecosystem, and I think it's something that we are all interested at it in LAS. The first tool that we are using in KDE is KPDocs. It's tooling that supports that powers api.kdE.org. So it's basically a API generator, so meta API generator, because it's built on top of Toxygen and also part of the KDE frameworks. So it has a stable API and often release of it is getting released very often. But more importantly, it's a sort of wrapper on Toxygen. And the reason why we can't use Toxygen only is because of two major reasons. The first one is that Toxygen is a great tool if you have one project and you want to generate the documentation for it, because you can just run Toxygen on it, create the configuration file, and run the Toxygen on the project. But it's getting a bit more tricky when you have hundreds of the libraries and the libraries depend on each other's, and you want to have a correct linking between the APIs or what the dependencies are clearly represented on your documentations. And Doxygen basically, KPDocs basically does all the manual work for you to generate all the linking between the libraries together. And the second reason why we want to have a wrapper around Doxygen is because by default Doxygen doesn't really look beautiful, and so there was a need to create a sort of more modern interface for the API documentation. It's also very easy to use. It's a Python package, and what isn't in PyPy, but you can just install it, clone the repo, and use it. And then it's just a command where you give it a folder containing all your projects inside it, and it will generate the documentation for it and do all the required stuff for it. And you are also adding support for Qdoc, so it's a Doxygen alternative created for Qt, but Doxygen is still the main tool used inside KDE because it supports C++, PHP, and other language. And this is how KPDocs looks like, with the API documentation on the left is generated, but also it does a lot of listings of all the libraries and some sort of own pages. Currently, it can't be really easily reused by other projects because there's some KDE branding on it, but it is something that I'm working on it to make it possible to have skins. So that you could have KDE skins with KDE branding, but those more neutral skins. And I'm mostly working on it for questions. So that because questions, matrix library that covers NeoChat, is not part of KDE, but I still think it's really useful to have API documentation for it generated on the web. The second tool that I want to present is DoxyQML. DoxyQML was required because Doxygen is a great documentation generator for C++ React, but doesn't support QML file. And a lot of Plasma is written in QML, and same with all the Plasma mobile applications with Kirigami. So we really needed something that works with QML. And it was written by Origato in 2012, but last year it was moved to the KDE organization. And while KPDocs, when DoxyQML is available, we'll use it, but it can be also used independently of KPDocs. So that can be used for every QML project that want to use it. The last tool is maybe what I worked on last year is a new developer platform for KDE. It's a centralized source for technical documentation because previously in KDE we had multiple places where we put our technical documentation. We had the framework cookbook, the TechBase wiki, the community wiki, the Human Interface Guidelines websites, the Plasma mobile websites, and the goal was to create some sort of centralized source for moving all these bits on one place. For the moment, I already moved 2 of the old places, and I'm working on moving all the remaining stuff to the developer.kd websites. It's based on Doxy, and it's Hugo-based themes for the computation. I'm a huge fan of Hugo, but there was a lot of unification compared to the Upstream project. So, for example, we support we added the KDE website branding, so that we have a unified style for all of our websites. And we also added tons of small helpers, for example, for linking to class and methods from the API documentations. And something that I'm still working on, it's adding internalization support. We already have in KDE a lot of tooling for translating websites, so that all our websites are available on multiple languages, and this is something that we probably work on the next few weeks to add the support to developer.kd or to it's this is how it looks like, the website at the end. So it's, and I don't think it can really be used by a web project. Although you can just see, but it's not something that can be easy. The small helpers can be copied, but otherwise tons of projects like this, like Sphinx, can be also used. Any questions? Okay, is the documentation updated at the same pace as the code gets new release and significant update? Is the documentation updated at the same pace as the code gets new released and significant updates? It's common to see many considerably big projects getting newer and newer versions, but the documentation is often forgotten, so to speak. So for the API documentations, it's part of the guidelines, but when you add new methods or classes, we need to add documentation for it. But for the more high-level documentation, this isn't really a guideline or requirement, so it's often getting updated, but recently we are getting better at keeping stuff updated. But at least for the API documentation, it's always up to date. Does the documentation contemplate the language used by all KDE projects? As someone wants to contribute to KDE apps, it seems most apps are C++. Currently the documentation is only for C++ projects. I think we only have 1 or 2 applications that has written in Python. Probably, we don't really even have a small tutorial of to build application with Python. It's probably something that we should create at some point. But we also don't have plugins for all the OR libraries in Python, so it's a bit of a tricky situation that we need to improve our language providings and the documentation rate at some point. What does documentation mean for user? Be mapped to system tooling.
Hi, Carl. Sorry to interrupt. We actually are out of time. We are at the 15-minute mark from when you started, and I'd love to invite you to finish answering the questions in the chat if you can.
Yeah, I can do that.
Thank you. Thank you so much for being here with us and for presenting.
Yeah, thanks for having me.
Okay, everyone, up
Bye.
next we have Valentin from who's talking about free desktop.
Yeah. So, oh, can I?
Wonderful. Hello. Thank you for
Hello.
being here.
Yes, I'm Valentin David. I work at CodeThink, and also I'm a contributor for Free Desktop SDK. And recently at CodeThink, we have been looking at porting Free Desktop SDK to RISC-V, and here is a small report of where we are at. So first, background: what is Free Desktop SDK? This is the main Flatpak runtime. So what are we talking about runtime? Is that Flatpak is like a container system for desktop applications, and for every container you need to have a base system where you have the shared libraries that are needed for the application. So this is what we provide. We are also the base to make the runtimes, the Flatpak runtime for Gnome and KDE. And there are also other applications other things that we do with Free Desktop SDK, including making bootable images for Gnome OS. At least we make the best so that we can make Gnome OS. Free Desktop SDK is not based on any distribution. It's all built from scratch, and this is built with Buildstream. Just to be clear, Free Desktop SDK is a part of Free Desktop, but what is in Free Desktop SDK is not necessarily Free Desktop, so there is no endorsement from Free Desktop when there is something in Free Desktop SDK. RISC-V, it's a instruction set architecture for CPU, and the specification of this is open source. So this is very nice that we are getting there where the hardware start to be open source. That doesn't mean that the hardware that we will have as RISC-V is necessarily open source. There would be bits that are not, but at least the specification of how the CPU should work is. There are RISC-V. There are multiple things. It can be 32, 64, 128 bits. So it's different processors. It's a set of different processors, and for each there is extensions for multiple different applications. For example, you might want to make a RISC-V microcontroller for very small embedded things, but you can also maybe make a processor for a supercomputer. So it covers lots of applications that need a microprocessor. But that also includes desktop, so we have to expect that we will see some desktop computer at some point that will use RISC-V. I hope we will get there. It's the right time for us, so we want to get the Free Desktop SDK to RISC-V because we know that it will be used, and it's the right time for us because first all the main parts of the free software have been ported to RISC-V, and this has started in things started to be merged upstream in 2017 with Lineages and GCC, and then later we got everything we needed. And recently, the last big piece for us, Free Desktop SDK, was merged, which was Go. It's not part of the Flatpak runtime, but we still depend on it for other things, like, for example, the Gnome OS things. So pieces are here. And also the second thing is that there is some experimental hardware that is going to be released soon that will be able to have some okay experience with desktop application. So it's nice to be able to test as early as possible. So to build it, first we targeted only one kind of risk. So the 64 with the main extensions that are expected to be in desktop. So this is a default actually for the 64-bit RISC-V for GCC. The development has not been that difficult because, first of all, Free Desktop SDK bootstrap part. So when we build the minimal system that has, for example, GCC, binutils, glibc, bash, mech, and things like that, this part can be cross-compiled. So we can make a port to a new system as long as we have the all the support in the toolchain. But the rest needs to build on the target architecture because there are so many projects that are very difficult to cross-compile, and we need to have so many patches to deal with it. So we don't cross-compile the rest. That means that we need hardware, but we don't have hardware yet in Free Desktop SDK, or at least we don't have hardware that is capable of building it because we need a lot of memory. So what we have done is using QEMU for emulation. In QEMU, there's two kind of emulation. There's the system emulation where you boot an OS, but there is also the user emulation where you can just say, I have a binary that is for a different architecture, but I want to run it on this current kernel that I'm running, which is another architecture, and it will translate the system calls to the current architecture. So you can just run the binary in your system. So we went for this user mode where we just execute the binary because it was better for us. First, we don't have to depend on a distribution that was built for RISC-V, so we don't have to deal with this. And we can build everything at once as we start to build something that to the bootstrap that does cross compiling, and then after we just switch to building on RISC-V, and everything happens on the same machine. It's also a bit faster, but the other thing is that we found that it hangs sometimes, and the main problem was cargo from Rust that was hanging. We have found that with just a simple environment variable, we could just work around this. Hopefully, one day we will be able to fix the bug in QEMU, but it's a very difficult bug to fix, but that works. So most of the upstream things that were concerned by supporting RISC-V, that as assembly, things like that, they were already supporting RISC-V, and the rest was just minor fixes. So we had lots of small fixes and lots of updates to make sure that we had the last upstream version. There are a few things that we didn't get to get, and two were mostly for debugging. So Valgrind, which is a very nice tool, but it's not yet available for RISC-V. Lib unwind, in practice, it can be used for a lot of different applications, but well, in theory, it can be used for a lot of applications, but in practice, it's been used only for debugging, and we can disable this, so we can provide a Free Desktop SDK without lib unwind, and it's fine. Another thing is that the per-compatible regular expressions don't have JIT compiler, so they might be a bit slower, but this is a minor thing. We have also looked at the Gnome SDK, and we have not found anything very special there, so everything should be there. What if you want to build your Flatpak application for RISC-V? Well, it's possible. You probably need to have some technical background, but it will be very quick. The first thing you will need is you need to have QEMU user on your machine, and you will need for RISC-V, and you will need to set up the BNFMT MISC so you can run directly the QEMU when you call any binary that is for RISC-V. The second thing is that you will have to build Free Desktop SDK. For the month, the Free Desktop SDK runtimes for RISC-V are not published yet, so you will have to build it on your own. Then after you will get a repo, you will have to install it on your computer. And then after, you will probably, depending if you use REST, for example, you will probably have to define the same environment variable that we used in your manifest. And then after, you just have to call Flatpak builder and just say you want the right architecture, and then it will build. And then after, you can test. Let's see. So a few months ago, we tested that. We wanted to be sure that we can build a Flatpak application for RISC-V, and this is actually running in the virtual machine. The result, this was super tux cart that we took from FlatHub, and we just adapted a few things, and we build it with the instruction I gave before, and this is running. By the way, what you see around is just a bootable test image that we have in FreeDesktop SDK that gets a bootable image that has a Weston and Flatpak, so we can test Flatpak. By the way, Flatpak works in RISC-V. There's nothing special about this. What now? We need to publish the FreeDesktop SDK for RISC-V. It will be published in August. There will be a new release, and that would be just for testing. We don't expect that this will be something really used, and this will not be on FlatHub. You would have to download it from the FreeDesktop SDK Flatpak repository. We need to get, we hope to get hardware soon that is capable of doing to build in the CI. So to have builder, so you will stop using QEMU. This is a temporary thing. We also need to prepare the builder images, because the way the CI works for FreeDesktop SDK is that all the Docker images that we use are based on FreeDesktop SDK. So we really do dogfooding, and we just use FreeDesktop SDK everywhere. So we will have to take care of that, but it's not very much difficult. We know it will probably work because we have all the pieces there. And well, the question is now when will we have hardware from FlatPub that is capable of building a RISC-V? That's a question that I don't have the answer. The work that was done on this project was done by a few engineers at Kotlin. A lot of commits came from James, so thank you for him. And FreeDesktop SDK is not a Kotlin project. We try to invest time in it and getting it there, but there is an independent there. So if you're, we need a community there, and we need more contributors. If you are interested, for example, in contributing in publishing the snap for a FreeDesktop SDK, we are looking for people who can do that in the community. Come on the RC channel. For Kotlin, we are hiring these days, so there's this URL. You can follow that, and all the information is there if you want to work at Kotlin. This is a short talk because we didn't know if we would have so much material to talk about, but there is more things that are coming at Guadex, so see you there. Are there any questions? I will go to the share notes. Yeah. Yes, so the first was when it will be available. The build will be for testing in August. It's already merged. So if you check out the master and you build that, you get it, and it's one command line make export with setting the arch to the right architecture, and it will just make your repository. Or it's what's in it for Kotlin? It's so we use this tool called Buildstream, which is also independent. It's an Apache project. But we provide consultancy at Kotlin, and one of the things that we provide is consultancy on building things and including Buildstream. So FreeDesktop SDK is a very good case for testing Buildstream and making sure that it works, and yeah, that's what it is. But also Buildstream is also independent. But it's just we need tools to provide consistency on. It just if we go to customer, we need to have some solution on things that yeah, that's it. Okay, how does RISC-V relate to ARM, which is currently popular? I think so I don't know much of the assembly part. I mean, how the technical part of ARM. I've noticed there is some similarity of how things are of the design. They are both RISC kind of processors, and they have some similarities in some of the designs. I think they're in the addressing, for example, and things like that. But I don't know the details. But the open source of the specification is a good thing, because the ARM is a company, and to be able to make an ARM processor, if you want to make a system on a chip, right, with some pieces, and it has the ARM core in it, you need to pay pay ARM, whereas RISC-V, you can choose with either you develop yourself the core, or you find someone else who will develop a RISC-V core that and you can change at any time of your design the core, and you stay on the same instruction set, so your binaries stay compatible. So I think I think that's the main important thing. And also, I know that, for example, for university, it's better to work on RISC-V than ARM for the issue of licensing with ARM.
All right, well, it looks like that's all the questions we have. Looks like that's all the questions we have. Thank you, Valentin, for being here and presenting for us today. Hope you get to enjoy the rest of the conference and have a nice rest of your day too.
Bye, everybody.
All right, we're going to take a brief break, and in about 10 minutes, we'll be back with a presentation from our sponsor, Collabora, in a sponsor's office hour. Again, taking a brief break for 10 minutes, and we'll be back with Collabora. Thank you.